Hello, all. Today, under the topic petroleum refining, we are going to cover the last topic known as refinery of the future. Refinery of the future is an interesting and an exciting topic that is going to talk about how the future refinery would look like. We are going to talk about the challenges for the industry, that is the petroleum refining industry. We are going to talk about the current level of automation. Where do we exist and where do we want to move on? And we are going to give a lot of examples or use cases for the digital solutions. And finally, the benefits of digital refinery, how it is going to help the business. So, let us try to understand the current challenges for the refining industry. So, currently, or for quite some time, the crude oil price is so volatile, and because of this volatility, it is difficult for the refiners to predict their top line and then bottom line. So, this is an perennial challenge. Then the second challenge would be tightening of the environmental and product quality regulations. Day by day, stringent regulations are in place, and accordingly, the process operations need to be modified or adjusted to meet the environmental and other regulatory requirements. Then the third important aspect is maintaining high equipment reliability, because petroleum refinery is one classic example of continuous process industry. Even if there is a small breakdown in particular unit, that is going to affect the entire production and even sometimes the throughput of the refinery. And the next challenge would be the reducing cost to remain competitive. So it's really tough to be very competitively advantageous position compared to the other competition. So you have to use all kind of technologies to remain competitive. The fifth challenge will be the molecular management of hydrocarbons. What does it mean? So today, splitting the crude oil into various petroleum fractions alone would not be sufficient. We need to come out with several petrochemical components either in the refining campus or in the downstream petrochemical campus. We have discussed in length about the petrochemical industry in the previous episode. Petrochemical industry has got a huge demand and it is going to give high returns on the income. So according to the needs of the petrochemical industry's demand, the several raw materials need to be produced from the refinery. The last challenge would be to have a sustainable operations. What does it mean? Zero incident and zero injuries. So the workforce need to go back home in a safe manner without meeting with any of the injuries or any fatality. So accordingly, all safety aspects need to be taken care, whether it is personal safety or process safety. So these are the current challenges for the refining industry. Today, technology has become so powerful. When we mean technology, so it is all related to IT and associated technologies like mobility, analytics, cloud technology, security, social media, then drones, robotics, etc. etc. So the technology has become so powerful. In refining industry, we need to identify the right use case so that this technology can be leveraged to a great extent, so that these current challenges of the refining industry can be taken care in a smooth manner. So now let's try to understand what is the current level of plant automation. So most of the data in a refinery comes from the field, that is from different kind of instruments, whether it is a open loop instrument or a closed loop instrument. So the indicators and controllers pump in so much of information to the control room. We have thousands of instruments, so many data is getting updated in the control room, which is not only consumed by the control room operator, it is also consumed by the process engineers, plant planning engineers, etc. So currently, most of the refineries have the basic things in place. So the basic things include the distributor control system, in short known as DCS system. In certain parts of the plant, then you also have SCADA. SCADA and DCS, they slightly differ. So while DCS is used for the entire process plant automation, SCADA is used for places like the yard, the cylinder filling operations or gantry operations, etc. So apart from DCS and SCADA, lot of PLCs, that is the programmable logic controls are there in place to safeguard the equipment and the personnel. Then you also have emergency shutdown system, which is an integral part of your plant automation system. On top of it, the refinery engineers, most of the refineries across the globe, they try to leverage different kind of technologies to do advanced process control, optimization techniques, as well alarm management techniques. So these are some of the basic stuff which are already in place, but today we are going to talk about more about digital solutions, how the digital components can help the refining industry with the help of the technology. So first let us talk about analytics. So today big data and analytics is a common topic across any industry, whether it is a banking or retail industry or an insurance industry. The oil and gas industry, especially the petroleum refining industry, is no exception to use the big data and analytics. So as I said in the previous slide, so the refining industry generates a lot of data with the help of instruments. Not only from the instruments, we also collect lot of data from the other assets like the fixed equipment and rotating equipment. So much of data is being collected, but how do we leverage all that data? So only with the help of predictive analytics, we'll be able to leverage all the data that has been collected for so many years. For example, input from equipment through IoT devices predict the performance of rotating equipment. Today, the rotating equipment performance is monitored by condition monitoring and traditional techniques. But in future or in the digital refinery, all the rotating equipments, the data, especially the vibration data and associated data, will be collected with the help of IoT devices. The predictive analytics will be performed, and finally the troublesome equipment will be identified for further action. Then predict the blend capability of different crudes. So today refinery is not limited to process a specific type of crude. So it is flexible enough to process different kind of crude, but when it is processing multiple batches of crude oil, so we should know how the performance is going to be envisaged. So all that can be envisaged with the help of the predictive analytics. Heat exchanger fouling, so they are all very specific use cases. The catalyst end of run prediction, the salt deposition, risk monitoring, quality giveaway prediction. So they are all very specific use cases wherein predictive analytics can be greatly leveraged so that surprises can be minimized. The plan can be run with a predicted way of planning. Then we move on to the next use case known as connected worker. So wherein the workers are provided with the wearable devices. So these wearable devices would be part of their safety helmet, or it will be part of their boiler suit. So the connected devices help the worker to be identified at any point of time. So with the help of a GPS technology, the operations chief will be able to locate the people, especially at times of emergency. So not only that, specific health parameters can be monitored like blood pressure, heart rate, etc. Especially when workmen, they are working in confined workspace, so they need to be monitored, and the instructions need to be given in a real time fashion. So accordingly, the connected worker solution has got a different kind of features. So it is going to enhance more rapid detection and responses to incidents to reduce plant downtime, and it is primarily going to reduce all kind of injuries to workman or fatality, and finally it is going to help the corporate mission of zero incidents and zero injuries. Then the next digital use case would be digital operator logbooks. In a continuous process plant, especially in refinery, the operator logbook is a vital document which is used by the operators who are working in shift. So it is going to help the incoming shift operator to understand what is the condition of the plant and what are the tasks to be performed in the incoming shift. So far, all these activities are happening with the help of a physical logbook, but going forward, all this can be digitized and digitalized. So, with the help of the digital operator logbook, all data will be part of your asset management system, and at any point of time, you will be able to go back in time and understand what went wrong on a specific date or a specific shift. So it is going to track the asset and the process performance in real time, and with the help of digital operator logbooks, you will be able to generate accurate and on time reports. And definitely, mobile devices can enhance the digital operator logbook when the operators have to go in rounds in the field. The next use case would be offsite emergency management. Whenever there is a incident like a fire or a spill, immediately the necessary stakeholders will assemble and then they'll control the situation. For example, the fire crew will be mobilized and the designated emergency crew people will assemble, put out the fire, help the victims who are affected in the emergency. Sometimes the situations go beyond the control, and at that point of time you may require help from the downstream industry as well as the civic community. For example, in India, so whenever the offsite emergency is declared, the district collector will take charge and he will be the chief coordinator to control the situation. He will mobilize all the paramedics and he will help people to uh, move out, and he will try to mobilize the forces like the police and other resources. So at this point of time, various stakeholders need to be connected. So this is where technology is going to play a vital role. So this solution will help to quickly alert the neighborhood industry in an offsite emergency situation and help to mobilize the civic resources, and including media, the clear and accurate information can be shared. Then comes the operator training simulator. Refining industry is a very complex industry, especially today. A lot of complex instrumentation, logics, interlocks have been put in place. Unless the plant people are trained appropriately, it is very difficult to run the refinery in a smooth manner. In order to train the operators in a efficient and effective manner, operator training simulators are becoming part and parcel of the plant automation systems. So when a new refinery is built, the EPC vendor is supposed to provide the operator training simulator along with the plant automation system. But going forward, so for every plant inside a refinery, a custom model will be built, and even the operator's training simulator would be accessed over web. The plant operators need not have to spend time to come to the training center. So from the control room itself, they will be able to attend the training programs. So these operator training simulators not only train the operators on different emergency situations, they are also going to be very helpful in training the operators for startup and shutdowns where lot of incidents are likely to take place. Then comes the smart glasses as well as AR and VR technologies. So here these are all very specific use cases where the operator can be trained even if he is in a field. With the help of AR VR technologies, with the help of the smart glasses, the operator will be able to scan a specific equipment and get all the relevant documentation in a smart glass. He need not have to go back to the control room. He need not have to go back to the drawing room to fetch the drawing. Since all the drawings are digitalized, so now with a click of a button or with a command, so these drawings can be brought to the field, and accordingly the additions can be taken. So it is going to help the field operator to a great extent, and this is in fact going to help the operators to have the anytime and anywhere learning kind of experience. Then we move on to another use case known as connected analysis. So generally the streams of the petroleum refinery, they are all sent to the quality control lab for analyzing the stream for specific test methods. For example, the gasoline sample is sent to lab for octane number testing. But there are specific scenarios where we don't want the time lag between the sending the sample to the lab and getting the results. That is where we try to install the online analysis, especially when the refinery streams are sent to the downstream petrochemical industry as a raw material. The continuous monitoring of the stream with the help of analyzers or online analyzers are very, very important. But the flip side of having online analyzer is to have dedicated resources. The technicians who are in charge of the online analysis need to be trained in a systematic manner, and if at all if these people leave the organization, then it is very difficult to maintain the analysis. The any breakdown in the online analysis, that is going to have a huge impact in maintaining the smooth operation of the refinery, especially when you are feeding to the downstream petrochemical plant. So that is where the connected analyzers come in place and help the refiners to maintain the health of the analyzers. With connected analyzer solution, you will be able to monitor the performance of different analyzers, however they are split across the different locations. So the performance can be monitored, and it will be easy to predict their performance, and the troubleshooting can be done in a seamless fashion. Then drones. Drones, once upon a time, the drones were considered not as a technology that can be considered in refinery. But today, refineries, they are trying to leverage the power of drone technology, especially when they want to do inspection in places where the human intervention is slightly difficult. For example, the refineries generally send all their liquid products through pipelines to their terminals and depots. So the integrity of the pipeline need to be monitored, and it is sometimes the owners of the refining companies. With the help of drones, the pipeline can be monitored. Any third party movement can be detected, or sometimes with the help of analyzers, you will also be able to find out any leaks happening in the pipelines. Similarly, the flare stack operations can be monitored with the help of drone based inspection. Generally, the flare stack is inspected only during the turnaround maintenance time. So, which is happening once in 3 years or once in 4 years, depending on the size and complexity of the refinery. But with the power of drone based technology, the flare stack can be monitored, the flame pattern can be detected, and if at all, if any deterioration has happened in the flare tip, that can be actively be monitored and attended in a proactive fashion. That is where drone is helping the refining industry to a great extent. Then robots for inspection. Their tank farms, whenever they are constructed, they need to be thoroughly inspected before it is commissioned to take in products or crude oil. The tanks which are in service, they need to be monitored on a specified interval so that there is no leak in the system. So tanks are susceptible for corrosion and leak, especially the bottom plates as well as at the welded joints. So the complete inspection with the help of manual power is generally difficult. But today, to solve that specific challenge, there are robots for inspection. They are known as crawling robots. So these crawling robots can start scan the every piece of the plates in the tank wall and across the 360-degree circumference of the tank. So every part of the tank can be inspected for any leaks or any gaps in the welded joints, and so that the reliability of the tanks can be ensured. So that is where the industry is leveraging robots to a great extent. Then robots can also be deployed for firefighting. Sometimes firefighting in refinery, though we have trained people, we have the fire tending equipments, firefighting engines, they are all available. Depending on the intensity, sometimes it is very difficult to put out the fire. So we need to allow the hydrocarbon to be burnt fully so that everything is under control. But this is going to take time, and in the meantime, lot of equipment, machinery, and even sometimes manpower can get damaged. In order to address the challenges, the robots are now put in place for firefighting. These robots can be triggered with the help of the pictures sent by the drone. For example, once there is a fire alarm is activated, the drones can send the pictures, and then the firefighting robots can be triggered, and immediately the firefighting robots can be mobilized to the specific location in the shortest time possible. And they are all tested for withstanding high pressure water jets, and they'll be able to change the angle of the water jet. They'll be able to adjust the spray nozzle. So all that is possible depending on the situation, and in real time they can be adjusted, and with the help of a remote control these robots can be maneuvered, and the fire fighting can be done in a very efficient manner. Then comes to the robotic process automation. Robotic process automation does not involve a physical robot as mentioned in the previous two use cases. So we talked about the robot based inspection, especially the tank inspection. Then we talked about the robots for firefighting, wherein the physical robots are deployed. But robotic process automation, actually it is a software solution to take care of the repetitive and voluminous activities happening in a industry, and it can be extended to the refining industry. For example, a big refinery having multiple refineries, they will have a very complex procurement system, and the procurement is happening globally, and a lot of manpower is involved in receiving the quotation, processing the quotation, and do the vendor rating, and finally the order placement, then finally making the payment based on the invoices. Lot of manual work is involved, and all this manual work are following certain workflow pattern, and these jobs are repetitive in nature, and the volume of task is very high. This is where robotic process automation or RPA can find a place, and this will drastically reduce the manpower, and since they are all automated, the the final output they are very accurate, and you can safely rely on it. You are going to have a error free business process in place. So today, many of the refineries have started deploying RPA in their procurement process, payroll process, HR functions where repetitive tasks are performed. This is going to reduce on your cost of regular operations, and finally it is going to improve your gross refining margin. And finally, we have the integration portals. Of course, portals were part of refineries even as on date. But going forward, the integration portal, they are going to connect all the key IT applications. For example, to start with the plant automation system like your DCS and SCADA system, not all the information from the plant automation will be brought into the integration portal. For example, the temperature and pressure may not be relevant for all the stakeholders. The planning engineers or the top management will be more interested in knowing the crude oil throughput in the refinery and the product yield patterns. So most of the flow related information will flow into the integration portal. And of course, from the enterprise asset management system, the downtime of equipments, the equipments which are under repair condition, and the cost of repair, mean time to repair, all such KPIs will be part of your integration portal. So apart from the plant automation system and the enterprise asset management system, inputs can come from your laboratory information system, which in short known as LIM system, and then HSC applications like your incident management system, etc. Because top management will be keen on knowing the KPIs related to HSC aspects, because they need to be shared to the external stakeholders, and they are also very critical in achieving the corporate goal of zero incident and zero injury. So here the integration portal can also act as a collaboration platform wherein people can use it as a single sign-on portal. They need not have to log into different applications using their credentials and password. with a single sign-on portal, they will be able to navigate different portals. For example, the plant operations manager can access the HR management system and identify who are all the operators they need to be trained, who are all the operators who are certified in specific category. So all that information can be collected within few seconds by going navigating into the right segments of the portal. And this is going to help the top management to take quick and accurate results. Most of the time the data collection and data processing involves a lot of time. For example, the process engineers generally tend to go to the control room and collect the data from the control room. How much crude oil has been processed, how much lube oil has been produced, and what were the temperature, pressure parameters. They jot down all these parameters from the control room and come back to their cabin, and then they start slice and dice the data to arrive insight into the specific plant performance. But today, with the help of the integration portal, all the data can seamlessly flow without any manual intervention, and people can spend their time in their core activities and not on data collection and data collation. So this is going to dramatically improve the plant efficiency. It is dramatically going to improve the productivity of the entire plant operations. I have just given few examples of the digital use cases, and definitely when the right stakeholders discuss, for example, the technology vendors, domain experts, and the end users, when they combine, they can identify more and more use cases. Finally, the benefits of digital refinery are increased market opportunities, increased plant availability and reliability, and increased leads. And on the other side, it is going to reduce the inventory cost, improved plant safety, increased plant efficiency. So that is what going to be called as refinery of the future, or digital refinery, which is going to leverage completely on all digital technologies, starting from mobility, analytics, cloud, robots, social media, security, drones, etc. etc. With that, we conclude the session on petroleum refining. I hope all these modules will help you to get a clear understanding about the petroleum refining industry, their business processes, and how it is impacting our economy. Thank you so much.